In just 1 year, the amount of denim used to manufacture jeans worldwide could stretch far enough to wrap around the earth approximately 75 times, creating a market worth more than $80 billion. To meet this enormous demand, the industry must operate massive weaving machines, centuries-old indigo dyeing technology, automated cutting robots, lasers that create faded effects, and finishing processes precise down to the millimeter. Today, join Factron Process as we explore the surprising journey of a pair of jeans, from a tiny cotton seed to a product found in the wardrobes of billions of people around the world. The story of jeans began during the California Gold Rush. In 1853, Levi Strauss arrived in San Francisco and opened a business supplying goods to the rapidly developing American West. 2 decades later, he partnered with tailor Jacob Davis and used copper rivets to reinforce areas of work pants that were prone to tearing. In 1873, the design was patented, laying the foundation for modern jeans and opening an entirely new chapter in the history of the garment industry. Originally created as durable clothing for miners, railroad workers, and laborers, jeans gradually moved beyond construction sites and into the streets, offices, and even major fashion runways. Long-established brands such as Levi's, Wrangler, and Lee continue to preserve the classic spirit of denim, while Diesel, Calvin Klein, and Gucci constantly transform it into high-end fashion products. Today, jeans are not only a familiar item in people's wardrobes, but also the center of a global industry worth tens of billions of dollars. A pair of jeans begins with white cotton fibers grown across vast fields. This is the primary raw material used to produce cotton yarn and denim fabric. In Mexico, cotton production is concentrated mainly in northern states such as Chihuahua, Baja California, Coahuila, and Sonora. In 2024, the country planted approximately 118,000 hectares of cotton and harvested nearly 480,000 tons of seed cotton. Chihuahua alone contributed more than 370,000 tons, equivalent to approximately 3/4 of the national output. Cotton plants require several months to grow until the bolls mature and burst open. A spindle cotton picker uses thousands of continuously rotating metal spindles to pull the cotton fibers from the bolls, after which powerful airflow carries them into a storage chamber. In the field, the seed cotton is compressed into large modules, wrapped, and transported to the factory. However, this material still contains seeds, dried leaves, pieces of stalk, and soil. Typically, only about 38 to 40% of the seed cotton by weight can become cotton fiber for textile production, so the entire load must undergo further cleaning and ginning. When the seed cotton arrives at the factory, it still contains dust, dried leaves, small branches, and other impurities collected from the field. The material first passes through an automated cleaning system that uses airflow, screens, and rotating cylinders to remove unwanted matter. Cotton gin then separates the seeds inside from the surrounding white fibers. The clean cotton fibers are compressed into large bales for easier storage and transportation to the spinning mill. At the spinning mill, the cotton bales are opened, loosened, and blended to produce fibers of consistent quality. The cotton then enters a carding machine, where rotating cylinders covered with thousands of small metal teeth continuously separate the fiber clumps, remove tangles, and align the fibers in the same direction. Fibers that are too short, tangled knots, and remaining impurities are also removed during this process. From the original loose mass of cotton, the carding machine forms a thin web of fibers and gathers it into a soft, long, continuous strand called a sliver. However, the sliver remains relatively thick, loose, and almost completely untwisted, so it must be drawn, evened out, and transformed into cotton yarn in the next stage. The slivers from the carding machine are combined and passed through several pairs of drafting rollers operating at progressively higher speeds. This process makes the cotton strand finer, aligns the fibers more closely, and redistributes the material to reduce sections that are too thick or too thin. Depending on the type of denim yarn being produced, the factory may use either ring spinning or rotor spinning technology. With ring spinning, the sliver is first drawn finer and lightly twisted into roving. It then passes through another drafting system before being tightly twisted by spindles, rotating at speeds that can reach tens of thousands of revolutions per minute. The twisting force binds the cotton fibers into a long, durable yarn with consistent thickness before it is wound onto small bobbins. In contrast, a rotor spinning system can receive the sliver directly. The fibers are opened, fed into a rotor, rotating at speeds of up to approximately 120,000 revolutions per minute, and joined into a continuous yarn. The finished yarn is wound into large packages, while ring-spun yarn must undergo an additional winding process before being prepared for denim dyeing and weaving. To create the characteristic blue color of jeans, the cotton warp yarns are gathered into large sheets and passed through a continuous dyeing system. Indigo is one of the oldest dyes used in the textile industry. It was originally extracted from indigo plants, while today most of it is produced synthetically. The yarn is not dipped only once. Instead, it repeatedly descends into the dye bath, is squeezed to remove excess solution, and is then lifted into the air. During this process, the indigo oxidizes and adheres to the outer layer of the yarn. The dipping and oxidation cycle is repeated several times until the required shade is achieved. The yarn is then coated with a protective sizing layer to reduce fuzziness, increase strength, and limit breakage during weaving. Once the dyeing and sizing processes are complete, the blue warp yarns are arranged in parallel, wound onto large beams, and fed into the weaving machine. Unlike a plain weave structure, denim commonly uses a 3x1 twill weave, in which each warp yarn passes over 3 weft yarns and then under the next one. This interlacing pattern creates the characteristic diagonal ribs on the surface, while giving the fabric a strong structure, good resistance to abrasion, and enough flexibility to be made into pants. Because the indigo-dyed warp yarns cover most of the outer surface, the right side of the denim appears dark blue. Meanwhile, the weft yarns are usually left in their natural white color and are more visible on the reverse side, making the inside of the fabric noticeably lighter. Before sewing begins, components such as the front panels, back panels, pockets, waistband, fly, and belt loops are created as separate patterns for each size. In CAD software, they are arranged closely within the fabric width while following the grain direction and surface orientation of the denim to reduce material waste. Once the marker is approved, the data is transferred to the automated spreading and cutting system. The machine lays the denim in multiple layers on a long cutting table, aligns the edges, and keeps tension low to prevent distortion. A vacuum system holds the fabric stack firmly, while a high-speed oscillating blade cuts precisely along the pattern lines. Smaller components may also be shaped with die-cutting machines. After cutting, the pieces are inspected, numbered, and bundled into complete sets before being sent to the sewing workshop, helping reduce defects and shade differences. Once cutting is complete, the denim components are numbered, sorted by size, and transferred to the assembly area. Depending on the design and fabric width, one pair of jeans may require more than 1 meter of denim, hundreds of meters of thread, and numerous accessories, such as rivets, zippers, metal buttons, labels, and a leather patch on the back waistband. Inside the sewing workshop, the production line is divided into specialized stations. One group of workers sews the front and back pockets, while others install the zipper, assemble the body panels, close the side seams, attach the waistband, or add belt loops. Each worker repeatedly performs a specific operation while the components of the jeans move continuously through dozens of different sewing machines. This organization allows the factory to maintain high production speed while controlling the shape and stability of every seam. High-stress areas such as the crotch, the top of the zipper, the base of the belt loops, and the corners of the pockets are reinforced with double stitching, bar tacks, or metal rivets. One distinctive detail inside the front right pocket is the small pocket commonly called the watch pocket. It appeared in the earliest workwear designs and was once used to hold a pocket watch. Although this item has almost disappeared from modern life, the small pocket remains as a familiar historical trace on today's 5-pocket jeans. Before leaving the sewing area, the jeans are inspected on both the inside and outside to identify loose threads, skipped stitches, puckered seams, misaligned pockets, or accessories that have not been securely attached. Jeans that have just been sewn usually have a dark blue color and an even surface. To create faded areas on the thighs, crease marks, scratches, or decorative patterns, the jeans are placed in a computer-controlled laser system. The technician selects a design, determines the processing position, and adjusts the laser power and scanning speed. The laser removes part of the indigo layer from the surface, creating lighter effects with high precision that can be repeated across thousands of products. For designs that require a naturally worn appearance, workers continue using sandpaper, brushes, or grinding tools to treat the thighs, knees, pocket edges, and seams. The rubbing pressure must be carefully controlled because products that are over-abraded, processed in the wrong position, or unevenly finished must be corrected before moving to the finishing wash. After the surface effects are created, the jeans are transferred to the finishing wash area. First, the sizing layer on the warp yarns is removed to soften the fabric and allow the treatments to be absorbed evenly. Depending on the design, the jeans are washed with pumice stones, enzymes, or a combination of both in industrial washing machines. This process lightly abrades the indigo layer, creates a naturally faded appearance, and softens the denim. Some products are also sprayed with PP or potassium permanganate on areas such as the thighs, knees, or pocket edges to create localized highlights. The jeans are then rinsed and neutralized to stop the chemical reaction. Finally, the products are softened, extracted, and dried, creating a wide range of styles from classic dark blue to light faded or distressed finishes. Before leaving the factory, each pair of jeans is inspected for color, dimensions, stitching, zippers, buttons, rivets, and the placement of faded areas. Minor defects, such as loose threads, skipped stitches, or loose accessories, are sent to a repair station, while products with serious sizing or color differences are removed from the shipment. Jeans that meet the requirements are cleaned, folded, labeled, and packed into bags or cardboard cartons. From there, the products move through the distribution system before appearing in stores around the world. From white cotton fibers in the field, a pair of jeans must travel through a long production journey before becoming a finished product. The cotton is harvested, cleaned, separated from its seeds, carded, and spun into yarn. These cotton yarns are then dyed with indigo, coated with protective sizing, and woven into denim with its characteristic diagonal ridges. But producing the fabric is only part of the process. The denim must also be turned into patterns, spread in multiple layers, cut by automated systems, and divided into dozens of separate components. The panels, pockets, waistband, and belt loops then pass through specialized sewing stations, while high-stress areas are reinforced with bar tacks, double stitching, or metal rivets. The finishing stages determine the final appearance of the jeans. Lasers create faded areas, crease marks, and patterns with high precision, while skilled workers treat areas that require a more naturally worn look. Stone washing, enzymes, and color treatments make the denim softer, lighter, or give it the appearance of having been worn for years. Before leaving the factory, every pair is inspected for color, dimensions, stitching, and accessories. A skipped stitch, a misaligned pocket, or an incorrectly placed faded area can send the product back for repair. The familiar pair of jeans is therefore more than an ordinary fashion item. It is the result of agriculture, textile engineering, chemistry, machinery, digital design, and modern automation working together. Originally created as workwear for miners and laborers, jeans have moved onto streets, into offices, and onto the world's largest fashion runways. Although styles constantly change, their durable structure and distinctive indigo color continue to give denim a special place in the garment industry. In the future, factories will have to balance production speed, cost, quality, and the need to reduce environmental impact. Technologies such as lasers, ozone treatment, automated cutting optimization, and resource-efficient washing systems may continue to transform how jeans are manufactured. Which factor do you think the denim industry should prioritize most? Durability, design, affordability, or environmental protection? Share your opinion in the comments and let Factron Process know which manufacturing process you would like to explore next. Do not forget to like, subscribe, and turn on notifications to continue joining Factron Process inside the world's largest factories.